For this video, we'll look at question number 2. It says the base of a solid is bounded by y equals 2 minus x, the x-axis, and the y-axis. Cross-sections that are perpendicular to the x-axis are isosceles right triangles with the right angle on the x-axis. Therefore, legs are perpendicular to the x-axis. Find the volume. Okay, so first off, I'm going to go ahead and try to sketch a picture here. Y equals 2 minus x would have a y-intercept of 2 and a slope of 1. Pretend that hits that point. Also the x-axis and the y-axis. So x-axis, y-axis. Okay, so we're looking in this space right here, and it says our cross sections are isosceles right triangles. So remember, isosceles means two of the sides are the same length, and if it's a right triangle, then it's got to have a right angle. So that's what our cross sections are going to be, and we need to place them such that the right angle is on the x-axis. So down here. Okay, so I think part of what can be difficult about these questions is it's really hard to visualize because it's hard to sketch, and fortunately I'm not very great at it either, but I would try to sketch in a few of these. So like here's my right angle on the x-axis as it says, and if I try to sketch this so here is one of the legs, and then the second leg needs to kind of come up if you think three-dimensionally, and then here is the hypotenuse. But before I forget, because my picture looks nothing like this, this is isosceles, so those are supposed to be the same length. So maybe if I try to sketch one more in here, here's the right triangle, this and this are the legs, and this is the hypotenuse. So you have to imagine that you've got a bunch of these isosceles right triangles. I just sketched in a couple to try to give myself a visual. Well, think about how you find the area of the shape. Since it is a triangle, it will be 1/2 base times height. And for us, the base, this is what I'm going to call the base, I know is the same length as the height, and the height varies. So the height here is a little bit more than it is down here. It varies based on x, but it's always this value. So that y value that was 2 minus x is this length, so it's also this length. And it's this length, so it's also this length. So the base is 2 minus x, the height is 2 minus x, and that's the area of one of these. So I'm going to go ahead and finish multiplying this together. If I FOILed this out, got an x squared minus 4x and a plus 4. Okay, so that would just be the area of one particular triangle based on the x value that you wanted to plug in. But we want to know what the volume of all of those are. So first of all, they're infinitely thin, and there's infinitely many of them. So the way that calculus is going to deal with that for us is we're going to be able to say integrate this. I'll pull the 1/2 out front, because remember, integration by definition is a way to add up the limit as n approaches infinity. So that's making sure that we have infinitely many of these, and they are infinitely thin, and so sometimes people like to refer to the thickness as dx. It's kind of like the width. And so now I've got my picture here. I can see the x values for y equals 0, x equals 0, and y equals 2. The x values are from 0 to 2. So I would integrate from 0 to 2. All right, and This looks like an easy enough integration we can do by hand, so let's go ahead and do that. Well, I might want to integrate it before I evaluate it, so evaluate it in the next step. So undo power rule, and undo power rule. I don't need a plus C because I've got my limits here. Okay, so if I plugged in 2 into all of these, I would get 8/3 minus 8 plus 8, and then subtract, plug in 0 to each of these, but 0 minus 0 plus 0 would just be a big 0. And I can also see those go to 0, so I'm left with this 1/2 that I pulled out front times the 8/3, which would give me 8/6, which reduces to 4/3.